Wait a minute. Let me put this on Instagram. But I need you so, someday. Hello, Michael Amanideep. How do you do? Let me put this on Instagram, man. Instagram. Am I audible? Am I? Do I sound very less or do I sound good? Everything is fine. Can we push the stream with it? Bro, why does sharing take too much time? Today I will complete logistic regression and proceed with what do you say? The data. Working with numerical data, categorical data, everything. I will work it with it. Where were you, man? Michael Amani, they missed you yesterday. Okay, so let me start. All right. Programming exercise. I was with Claude. I don't know where the hell I kept the. Uh, what do you say? Ooh, 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 ooh. So yeah, let me start. I was at step 4 when I needed to train the logistic regression model. Let me open that Google Colab. Google Colab. Oh, okay. Why is everything so zoomed up? Where are my files? Where did my files go, man? Open notebook. Yesterday I did this, I guess. Yeah, all code is here. I'll make a quick summary of what I did yesterday. First, I did downloaded OpenPy Excel, which was for reading Excel files. Pandas was for what do you say? seeing your data set as an Excel sheet, so that you can visualize. And let me zoom more. NumPy was for array operations. Matplotlib was for like visualizing with graphs. And coming to sklearn, it's a very important library in machine learning. Let's say sklearn.model selection. From this we import train test split. It is required to split the data into training data and test data. So yeah, and next is sklearn.preprocessing. Standard scaler is so that we treat all those x and all those features equally. Also that one which one feature which has a higher value doesn't dominate the other. Okay, and linear model is for like telling which model we are gonna use in this, and metrics would be accuracy score. Accuracy score is TP plus FN, TP plus TN by total of it, and precision score is TP by TP by TP plus FP. Recall score is TP by TP plus FN. Confusion matrix, let me check once anyways. Accuracy, recall, precision. What were those formulas? Let me zoom this in. Yeah, I was right with the accuracy. Uh, recall was, yeah, TP by FN. Okay. And TP by TP plus FN is a recall. And what do you say? What was next? Precision was TP by TP plus FP. Rock curve was receiver operating characteristic curve, where you plot the graph of TPR versus FPR. And rock awk score is awk is the area under the rock curve, and the area under the curve, whatever the line is covering in TPR versus FPR graph, is known as the awk. The whole area, the whole value of area is awk. We could find it by integration, I guess. And confusion matrix is true positives, false positives, for false negatives, true negatives. Okay. Now when I move in the threshold values, when I increase the threshold, TPR, increase the threshold, true positive and false positive decreases. So precision increases and the recall decreases when I go from left to right in the threshold, and when I go from right to left, the negative decreases, which is a false negative and true negative. Since these both decrease, recall increases. Since Fn is in the denominator, recall increases. Okay, and yeah, precision were reverse of each other. That's what we know. And confusion matrix, yeah, done. USIML repo is our data set. It has a data set which, what it does is, let's say, uh, it has like rice features, rice's features like, move this camera, yeah, rice's features like what do you say, area of the rice, length of the rice, type of the rice, everything, so that we could classify either in Osmansic type of rice or Cameo type of rice. Okay, we fetch the repo in the rice variable, Then in X raw we store the data dot features. In Y raw we store our target, that is the output which the logistic regression is supposed to give. Now I convert this into a data frame. In data frame, how do I convert it? It is from what do you say, the pandas. Okay, copy function, df is equal to x raw dot copy. This will put it in the data frame, and in class, which class of the rice it is, this will put the y contain osmansic or cameo. This will put the all of those in the class column. Okay, this is to tell us what's the size of the data set, like how many columns, how many rows. Head shows us the top 5 rows. I have area, parameter of the rice, major axis length, minor axis length, eccentricity, convex area, extent, and finally we have classes which is hidden. How do I zoom out it? Yeah, class cameo or osmansic. Okay, now D types tells us all those features available in a data frame and all their uh, data types. Okay, area is an integer value, perimeter is a float value. Df class dot value counts how many values are there. Osmansic has 2180, cameo has 1630. Okay, now print df is null dot any means is null will return as the column names. Wherever it's false, it's true. If it's null, it will print true. If it's false, it will print no. If it's null, it will print true. Okay. If it's not null and there is any value, it will print false. Now, when I do dot any of it, this will like give me a column name where there is a column or a row name where there is a null value. Okay, then I do any again, this will search the exact element which has a null value. Okay, so 2 times any. Okay, then df dot describe dot round of 2, this will tell me all of the features of our data set. What is the mean, what is the standard deviation, what is the minimum value, what is the maximum value, everything. Okay, yeah. Now when I come to visualization part of this data set, I come to the matplotlib library. See, I have 7 features in this ex column. Okay, and one target which is class of the rice in y column. Okay, now I need to plot 7 graphs, y versus x1, y versus x2, y versus x3, all of this. Okay, see, I create 8 plots. Figure size is 16,6, 16 inches, 16 inches wide, 6 inches tall, and axis is equal to axis dot flatten. Now axis is an like 2D array, dot flatten will make it a 1D array. Okay, so that it's easy to do calculations. As you can see, we have put it in the loop. Now for I comma feet in enumerative features, enumerated, what enumerate does is it lets you iterate at a single time with both index and value. Okay, so now here I is index and feet is the value of that particular index. For cls comma color, cls is the class, color is the color we need to visualize it in. Okay, if it's osmansic, we will visualize it in steel blue. If it is cameo, we will visualize it in coral. Okay, now axis of I dot hist. Now axis of I dot hist means histogram, to plot a histogram of this. Okay, df of what will be the values, it will have at that particular iteration, let's say the class is Osmansic, I need to put it in the Osmansic I need to put it in the class column, and I need to get only data for Osmansic and its features. Okay, this will plot 7 graphs. Then Cameo, it's squirrel, beans are 40, alpha is 0.06, labels will be CLS. Okay, see, as you can see, these are the labels: Osmansic, Cameo. Hmm? Color is color. Then access dot set title. Set title would be the okay, yeah, this is all you leave it. Okay, next comes splitting those data. Okay, x is equal to df features dot values. In x I store the features values. Okay, since I need to work with numerical data, I can't work with strings and all for logistic regression. Then one second, my mom was calling. One second. I will be back in a minute, guys. Sorry. I will be back in a minute. Okay, I'll be back in a minute. Give me just 1 minute. I'm back. I had lost my keys, I was searching that. Anyways, so yeah, I'm back, my bad, my bad. uh, X is equal to df features dot values. Since we need to have what do you say, numerical values to both of them, that is x and y values. So what we do is x we store the values as it is. See, x has values already, so we store it. Next what we do is y is equal to df class is equal to osmansic as type of int dot values. That is, if it's osmansic we will keep it as 1, if it's cameo we'll keep it as 0. Okay, now xtrain comma xtest comma ytrain comma ytest, this is the split. Okay, train test split x comma y. X train we store x comma y. We test size will split it into what do you say, 20% of the data set will split it into test. The AI should, the model shouldn't see it. And random state is 42, that we, so that we don't get new random split all the times every time we rerun it. And scalar is equal to standard scalar dot fit transform. Fit transform, I get, yeah, I told that before, so that features with larger values don't dominate. That's why we do fit transform, and we don't do fit hyphen underscore transform for test data, because it will cause the data leakage. That's why we don't do it. Okay, let's start the model training, guys. Let's freaking go. Let's freaking go. Model is equal to logistic regression, and in this we'll put some parameters. Max iteration is equal to how many? 1000 iterations, and random seed is 42. I don't think this will run, because I think I need to run, yeah, I need to run the older cells, because it's been time since I ran that. Okay, let me run this. Run all. Yeah, this would run all of these cells from beginning. Random state. Let me put the charger. Yeah, back. Random state is equal to 42. Random state is equal to 42. Yeah, random state is equal to 42. Let me run this again. This should run. We loaded the model successfully. Now we are going to train the model. What are the, with what? Model dot fit x train comma y train. This should train the data. Then Now let me just. I don't understand what this does is. I don't remember what zip function was supposed to do. Let me ask Gemini. Explain this step by step. For feet comma coefficient, this is the for loop that iterates to two lists simultaneously. Oh, okay. I remember. Zip was for running two lists simultaneously, and name of the features, and model dot coef, which contains the learned coefficients for each feature from your. Uh, okay, the zip function pair is sub corresponding. Okay, okay. Okay. So let me first print this training complete. Y train is small y, not big Y. Okay. Why there is a space in between? No space. Then I say, then what do I say? Random state was like random state. We keep it as 42. 42 is an inside joke they told. And why do we keep it 42? We can keep any number, but why do we keep any number, any specific number? Why do we even specify random state? It is because every time I rerun the uh, a cell, that particular cell, every time I'm splitting the data set, I don't want very random examples to be split again and again. Uh, I want that proper values, so that if I rerun, 80% should be this almost same as the first time I ran it. Let's say I ran this collapse cell. I send it to you guys through GitHub. You guys run it. You will have very different, completely different values for 80% and 20%. So instead, if I specify random state, it will be like almost similar to what values I had in 80% and what values you had in the 80% and 20%. Okay. Let me just again print this. What the model learned, the coefficient is what we are gonna do. I don't know what coefficients one for feature means. It's 9 now. For I, sorry, for coef only, right? What did he take? He take features one first. Okay, feet, comma coef in zip of features, comma model dot coef. Yeah, coef 0. Then I say print feet I don't think so. Okay, yeah, this is enough. Feet should be 22, right? Feet should be 22. Uh, guys, support. Coefficient is should be 4f. Let's train the model. The model trained also. Eh? The model trained so soon. Linear regression took like 50 approaches. Angie? Let me ask Gemini. We don't have epochs in linear regression, sorry, in logistic. Why do we study, make the model train 50 times or something epoch value throughout the data set, and why is it only once and in seconds in logistic regression? Logistic regression involves solving a complex convex optimization problem. This means there is a single global minimum for its or more advanced solvers are designed to find its minimum efficiently, though you don't need to iterate through the data multiple times in same way or deepening. Okay, there was something called conversion in linear regression, if you guys remember. When I'm doing gradient descent, the graph was decreasing gradually and then converging. No, so, less loss. So that was convergence, but here it's convex optimization. Okay, in convergence we have like multiple approaches. We read multiple times, and since it's convex optimization, it involves only one minimum, so it's done. Okay, we train the model so soon. Okay, let me check what the output means. Means that as the feature value increases, the log odds of the rise being Osmansic. Means that the feature value increases, the log odds of the rise being Osmansic decreases. This implies that Harris values will make it more likely to be classified as cameo. Magnitude, the absolute is the log odds of being Osmansic. Okay. Oh. Okay. And perimeter, a moderately strong negative coefficient. A larger makes it considerably less likely to be Osmansic. Okay. A strong negative coefficient, a longer major axis length makes it considerably less likely to be minor axis. This will increase the Osmansic. Okay. Eccentricity, this will less likely be Osmansic. I understood. Let's move on to evaluating a default threshold. Since we require more recall, and my agenda is to decrease false negative. To increase recall mean decrease false negative. And how do we decrease false negative? We move from right to left, right to left to decrease the false negative. So that if we move from right to left, threshold value decreases, and we need to choose a lower threshold. That's what I feel. Okay, let me just see what this does through Gemini. Why dude, I can't run all of those again. Come on. Do I need to run this again? Yeah, I need to run this again. Anyways, we'll be learning here. Guys, please introduce yourself. You know, six of them. You can tell us about yourself something. I'm not saying what a dumbass man. 12 watching now. Can you guys please introduce yourself? Probably like. It will be better. Now, what it means is model.predict probab extends this method from the logistic regression model calculates the probability. That's good, man. R Adhan 6969. Radha N 6969, I guess. That's good. Keep it up, you know. Model that predict probability X test. This method from the logistic regression model calculates the probability of each class from for each sample. Okay, okay. It returns a 2D array where each row corresponds to a sample. Yeah. Learn it's a very good start. You can learn. Radhan, he is a boss in Elden Ring. I don't know what that means, but anyways, respect boss. It returns a 2D array where each row corresponds to a sample and each column represents the probability of that sample belonging to a specific class. Each column represents, okay, I know that, yeah. For a binary classification problem like this one with Cameo and Osmansic, it typically returns two columns probability of class 0, probability of class 1. Okay. Oh, I might have heard Elden Ring. I do know, man. This slices the array to select all rows and this only the second column one. Since Osmansic was encoded as one, as seen in yeah. Okay, sure. The predicted probability is that each sample index belongs to the Osmansic class. Okay. In this, we are predicting how many Osmansic classes are there in X text. Thanks, Radhan. Good luck to you too. Keep grinding. Then why predicts? This slice converts the predicted probabilities into binary class predictions. We are keeping this as thresholds. Okay. If it's greater than 0.5, we'll tell it's 1 and it 1 means Osmansic. And if it's 0, we tell it's Cameo. Okay. Let me just try this. Y probability is equal to model dot predict proba means probability and we put X test data in it and we get all of the rows all for all features, and one only one column, which is Osmansic. Next we say y prediction. Now we need to classify, right? Y prediction is equal to y probability greater than zero point 0.5, zero point 0.5 I guess, dot as type int. I think I am good with this. I need to even include the 0.5. Okay, oh, it looks good. Y test, Y prediction. Okay, now we calculate accuracy. Ac is equal to accuracy. Accuracy is Y test. Do we put it in the, yeah, Y test? What is the Y actual Y test outputs, and what our model predicted? Okay, this tells us the accuracy. And precision should be same. Do we calculate the same? Yeah, everything we calculate the same. Precision is equal to precision Y test, recall is equal to okay. Then what we do, then we need to print them, but before that we need to draw a confusion matrix. Okay, then we need to display that confusion matrix with display labels as Cameo and Osmansic. Display dot plum cmap. This is from the matplotlib. Let me do this quickly. Print accuracy as yeah man, Aryanchi, you can learn. You look so excited. Precision is 3.34. Recall is 0.3f. Dude, I think we should all make a group in uh, Instagram or something, you know, a Instagram group where I put up polls or something. Whoever is joining to learn tomorrow, we'll start this topic tomorrow. We'll do this tomorrow. We could discuss a day before. Put me on Instagram. Do you know my Instagram? RNG. Then I need to print the. Yeah. Will do. And CM is equal to confusion matrix. Hello, Sayan Avari. I am sorry, man, if I'm pronouncing wrong. It's Sayan, I guess. Sayan. Hello, bro. How do you do? Confusion matrix is Y test, comma Y prediction. Then we come here. Then we have display. Display is equal to confusion matrix dot display. We CM and display labels are Osmansic and Cameo. Display dot plot. Then what we do, display dot plot cmap is equal to blues. What's cmap is equal to blues? Does anyone know what cmap is equal to blues mean? Capital blue or okay, blues. Hey, blues. And plt dot this will I just copy it. Let's go. What's the issue? Name accuracy is defined, not defined. Accuracy spelling is wrong. Henji? Accuracy score. My bad, my bad, my bad, my bad. Accuracy score. Accuracy score. Score. Then we have recall score. Now I understand. Nah, man. In print statement, I have issues. Accuracy, confusion matrix. Let me see what it was. Confusion underscore matrix. Confusion underscore matrix should be fine now. Is it? It is fine. We have accuracy of 0.91 and precision of 0.915 and a recall of 94%. This is TP, true positives and true negatives, and we have false positives and false negatives. Okay, since I need a recall more, I think we need recall more. We should prioritize recall more here. Let me tell you why we need recall more. I don't know. Precision is also same, recall is also same here. If precision is low, it will go to the Osmansik instead of Cameo, and Cameo instead of Osmansik. If the recall is low, it will go from Osmansik to Cameo, false negative, false positives. Let's keep it font 5. Who cares? The rock curve shows TPR versus FPR at every possible threshold. Okay. Damn. Damn. How many? How many? 2 more steps. 3 more steps. We have 3 more steps, then we'll wrap up logistic regression and start with the data. Okay. FPR, TPR. FPR is false positive rate. If anyone doesn't know, false positive rate. False positive means a value is negative. A value was supposed to be negative, but your model predicted it to be positive. Then you said false positive. And how many false positive rate? The more the false positive rate, the worst, no, the worser, no, the badder. My English is badder. The worse is your model. The more FPR, the worse is your model. TPR is how many positive were supposed to be, and how many your model predicted. Okay, that's TPR, and it's 100% TPR. Then it's your model is so good. That's ideal basically. And thresholds is classification used in binary classification. At this value, I will classify it to be this class. If it's at this class, I will classify it as what do you say, Osmansik. At this value, I will classify it as Cameo. That's what the threshold does. Now we need to plot the graph. How do we plot the graph? FPR, TPR, threshold is equal to rock curve. Rock curve needs two things, TPR and FPR. How does it do? Y prediction, we just put Y test, Y prediction. Okay, that creates the rock curve. Now how do I calculate the awk score? Awk is equal to awk of score Y test, Y prediction. Simple as that. Now we just plot it. plt dot plot. अबे यार इतना सब क्यों भाई. plt dot figure. I need to create a figure of first. I need to create the figure. Figure box. How much box it has? No, what's the size of the box? This will mean 6 inches length, 5 inches height. Okay. Next, plt dot plot fpr comma tpr. fpr will be the y-axis, tpr will be the x-axis, and label you see on the top right. It would be label. He has given something else here. Okay. Color he had given same, but its color would be steel blue. Okay, I need color. Color should be steel blue. Color should be steel blue. Okay. Then what I need? Then LW. What is LW? What is LW is equal to 2 in matplotlib. What does it mean? It's a shorthand for line width is equal to 2, which indicates the thickness of the line. Oh, okay. LW is equal to 2, comma. Then what do we do? Why do we require random classifier? Wait a second. Now plt dot figure, I did it. plt dot plot is fpr comma tpr. Color is equal to steel blue. I am done. I understood. Where I am not understanding is from the random classifier. What does random classifier here do? What does plt dot plot random classifier here do? Ta-da! Guys, subscribe, like, comment, share, evaporate. We are 664 followers on Instagram. We are 664 followers on Instagram. RNG, let me share my IG. Let me check my IG first of all. Dripstone 2. Yeah, I'll put it in the chat. You can search it on Insta. A person wearing a white t-shirt and suit as the PFP will appear. You can go follow him. You'll be shocked seeing the views here and there. There's a lot of difference with the views when it comes to YouTube and Instagram. performs no better than random guessing would have an equal chance of correctly and finding. Ah, my bad, Aryan. Aryan, my bad, Aryan. Sorry, don't mind. I'll call you Aryan from now on. Then what we do? This is why do we plot a random classifier, guys? It's a very interesting learning. We need to see if our model is worse than a random classifier. A random classifier simply puts uh, negative random values, man. Randomly puts positive randomly. We need to see if our model has less accuracy than even the random classifier. That's why we are plotting this. Okay. We'll draw a straight line 0 to comma. It will flow from 0 comma 1 and 1 comma 0. Sorry, 1 comma 0. Then what we say, this is the type of line. Then I say color should be gray of it so that it doesn't attract myself. And label that you see on the top will be label would be a random classifier. Random classifier. We are done with this. Now we need to plot the threshold also. Okay. IDX is equal to ND argmin. What the fuck is this? Yo, Varun is 373. Varun is 3753. I am Dripstone 8094. Explain this. This code snippet is used to, I understood that. We need to show the threshold there, threshold point. The threshold point will tell us कि after this value, I will consider it as Osmansik, and below that value, I will consider it as Cameo. Okay, bro, I saw you on Instagram yesterday and I didn't know it was you. I'm just like that, you know. I was shocked seeing that. Let me screenshot that. So I remember this moment. Probably someday when I grow as an YouTuber. Abey, this is not taking a screenshot. Yeah, fine. Yeah, neural embedding when went most viral. It got like how many views? Like I guess 1,24,000 views. Back to study. IDX is equal to np.argmin. Thresholds means the value. Okay, is an array of all possible classification thresholds written by Rock curve. For each threshold, there is a corresponding false positive rate and true positive rate. Okay. Threshold minus this calculates the difference between each threshold value and zero point 0.5. Okay. np.abs. This takes the absolute value of those differences. We are interested in threshold that is closest to zero point 0.5, regardless of whether it's slightly above or below. Okay. np.argmin. This function returns the index of the minimum value in the array of the absolute differences. So idx will be the index of the threshold in the this function returns the index of the minimum value in the array of absolute differences. Okay. So whichever value has the lower, less difference compared to the actual threshold, which is 0.5, that will be given by ABS. Now argmin what it will do is it will return the index of that value. Okay. Now let me do this. Okay, in code. idx is equal to index only. Why did I not understand? Coming here, idx is equal to np.argmin of np.abs. The only apps I have in my life. Threshold spelling, threshold, 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 thresholds. Oh, all the thresholds, right? Thresholds 0.5. Okay, na Sudeep. Wait. Oh, I took threshold. I need to put it thresholds. Okay. Then idx is equal to np.argmin, np.abs, thresholds is 0.5. Okay, na? Then what I do? Then I do a very interesting thing. Then I plot this thresholds which I got. PLT dot scatter. Scatter is for scattering those points. Okay. PLT dot scatter. I have a graph right now. I need to scatter those points on it. What points? Thresholds. Okay. Now FPR of IDX. FPR of IDX. What the fuck is FPR? FPR is like false positive rate. Okay. Yeah, false positive. It was supposed to be negative, but your model said it's positive. That's false positive. Okay. This plots a single point on the. Okay. These are the false positive rate and true positive respectively that correspond to the thresholds closest to 0.5. Oh, okay. FPR, we need to find values which are closest to the these values. FPR, NDX, then TPR of IDX. Then what we do? Then what parameters do we need? S is 80. What is S is 80, ma? Says the size is 80. I don't need size as 80. I need 100. Then color is red. Color is red. Let it be red. Okay. Then what we do? Z order. What is Z order? Ensures this scatter point is drawn on the top of other top plot elements. Why do we have so many parameters? Why can't it just understand by itself? Why do we need to put so many parameters? This is that, this is that, and label is this one. Just copy this long ass shit. This basically means the threshold, to be honest. Oh, and we are done. We're ready to plot, I guess. This is X label, Y label, X title, Y label, and aux score also will copy. Paste. Let's run this. Let's fucking go. Let's build this. Syntax error, beautiful syntax error. Where ma? Name awk score is not defined. Awk ma, awk, not awk score ma. Sudeep. Now run this. Still a issue. Where? Where is the issue? What should I even do that error, man? Eh? Not supported between instances of str and int. Very good. We don't support it. That's very good. But what should I do? That you should tell. Our free piece Gemini. What was the issue? Oh, I put it as a string. It's okay. You can just say it directly, right? Why did you put Z dollar? You know, you can say it with love. What's such a big deal that you show it as a big as fuck error? Damn, this is the, as you can guys can see, this is the curve, rock curve. Okay, TPR versus FPR. Okay, now awk is 91. Okay, now all good. This is the threshold. The red is the threshold, which is 0.5. Okay. No, yesterday before Michael Amanidi, before yesterday when I went live, uh, many people came before uploading the reel. No, no, not yesterday. Yeah, probably because of the reel, I guess. But many people are not coming from Instagram. They're coming from the YouTube. It's the power of thumbnail. Train a second simpler model using only two features. Overlaying both rock curves on the same axis shows on step 7. Changing the threshold shows how cautious the model is. Lowering it increases recall. This step by step so that I can code parallelly. Like the stream, guys. There's only one like I guess on the stream. Oh, there are 8 likes. Why it's showing one like here? 143 subs. Oh my god, 4 people of them subscribed. Thank you so much, man. I'll put long videos here for my YouTube family. Because YouTube family is better than Instagram family. Cause 7 of them watch and 4 of them subscribe on YouTube. On Instagram, 1 lakh people see and 15 of them follow. You see the loyalty difference? Bro, I can't understand shit. What is this paragraph? Damn, how do I? Damn. How would someone read this? Is it even possible? ChatGPT bhaiya, come to me. Explain this step by step so that I can code parallelly. We'll build something, guys, everybody. We need to do so much in our lives. Thresh values create threshold values. What it does is it creates the threshold values that we know. Okay, generates 200 evenly spaced values from 0.011 and 0.99. That is 1% to 99%. We have 200 threshold values. Okay, because in classification you just don't use zero point 0.5 threshold, you test all of this threshold. Okay, you never know which of the threshold, which of the threshold value you should use. We need to perform these operations which are doing now. Thresh values is equal to np dot line space. I know that lean space np dot lean space 0.01, sorry, 01 to 0.99 comma till what? No, 200 evenly spaced. Atharva, tell me like what and all you know, man, so that I can help you out. Atharva Keluskar, tell me like what and all you know already. Okay, everything. Don't be shy. Don't be shy. Open up yourself. I'll help you out. Precisions, comma recalls, comma accuracies is equal to we initiate a blank arrays. Precision is equal to accuracy, comma recall is equal to, we create a blank arrays. Okay, start with Google's machine learning crash course. That's what I am learning with right now. Okay, don't spend a lot of time, man. You know, you'll be learning machine learning for like months and months and months and months. Till then, there will be 10 to 20 topics coming on Gen AI. I believe machine learning, you should learn it as a basics so that it helps you out in your projects. Learn from Google's machine learning crash course. Loop through each threshold. For tree in threshold values, will loop. Okay, understood. For t in threshold values. Okay, understood, pa. Next, water. Now we test the model performance at every threshold. Okay. We convert probabilities into predictions. Okay, okay. Before we did it for y, sorry, point 0.5. I have messaged in you in your IG. Can you share that link? I will share it today. I'll put it on story. All or I will either make it crash course, I guess. No, I'll make a reel, I guess, if it's fine. I will even send you, but I guess I will probably make a reel too so that people know and people will actually believe because even I am studying from it and they will also study. Dude, Atharva, see, that's great. Okay. Next step is linear regression, logistic regression. Then we are done. When you are done with it, as you can see the column here. Let me zoom this out. How do I scroll with this, man? See, you have this. This is what you have done with, right? Data sets, imbalanced data set, dividing the transforming data, everything. Okay, these are all easy topics, man. After this, since you have done this, you jump with linear regression and logistic regression. After that, wait a minute, sir. After that, you come to neural networks, embeddings, large language models, everything. Then you come with real world ML, then you jump to projects. As simple as that. Catch me up, you can even see my older lives. Okay. Like I am learning from like same way. I am not learning after the stream or something. I come here blank, I study here. You can just see the oldest streams, I guess, if you have any doubts at specific points or something. Linear regression and logistic regression. That's what you need to do next. That's the entry point for machine learning. Y probability is equal to Y prediction. Y probab is greater than or is equal to T and hash tab is equal to T. Okay. Then what you say, if probability is greater than threshold plus we say else 0. Okay, okay. Okay, okay. Understood this as, yeah, most of the time you work with linear regression. You work with epochs, everything. Most of the time it's linear regression itself. Yes, let me go a little deep. What I am doing here is prediction is equal to y prob greater than or is equal to t dot as type int. Here what I will say do is prediction. My logistic regression model outputs in probability. Linear regression gives direct prediction. Logistic regression gives in probability, that is 0 to 1 likelihood. Okay, probably this value, probably that value, that kind of. Now what I say here in this line is y probability is greater than or is equal to t. That is, t is threshold. That can be any values. Try to create any simple website or workspace and update day by day course or what we have learned today so new viewers can catch up and see the materials and codes. Ooh. Nice idea, Michael. Money deep. Wait, I could also create a reel out of it, right? I am learning this, and instead, if you join late, you don't need to worry. You can just go to this website. You can look it up, right? I can do that. Love you guys, man. It feels so good to have you guys on stream. Then what I say, y probability, the probability value which the model gave output is if it's greater than or is equal to t. T is threshold. Threshold is like border. Okay. At this border value, after this border value, you would say it's Osmansic. Below this border value, you would say it is Cameo. Okay. Osmansic is the class of the rice. Cameo is also the class of the rice. From where should I learn next topics? You would learn from Google's machine learning crash course. Don't be watching long YouTube tutorials, man. You'll be drained out. As an engineer, you should be learning from. I'll make it, man. Aryan Chaudhary and Michael Amanidip, thanks for the idea. I'll make it. Probably today or tomorrow, I will make it. No, it's not a course, man. It's free. You think I would buy the course? Seriously. You think I would buy the course? If I had to buy, I would buy a green screen and a camera. I'm recording in my laptop camera, you can see the quality. Everything is free, man. You don't need to pay for anything. I'll build it, Michael. I'll build it in. It will be in minutes. What I need to do is get a YouTube API key so that it gets data from my channel, and I'll set up a AI in that website so that you can learn from that. See, after this course will be uh, available in what do you say, GitHub. This courses will this code will be available in GitHub, and I'll share this GitHub link in the comment section after the live, and it will available at the website too. You guys can check the which live you can study with everything. I'll make it. That's a good idea. Back to studying. Back to studying. I need to convert probabilities into predictions. You understood this one, right? I wrote it in the code. I wrote it. Okay. Next, you come little bit down. You say compute precision. Precision, not precision. Precision. We took the predictions. We need to calculate what the precision of our model is. What is the formula for precision? That is true positives by true positives plus false positives. How many of those positives the model predicted, in how many of them positives were actually positive? That is true positive. Okay, and how many of them were not is false positive. This is the formula, as you can see here. TP by TP plus FP. TP is true positive, FP is false positive. Okay, out of predicted positives, how many were correct? See, ChatGPT is only me. Me is ChatGPT. Then after this, ah, precision dot append. Precision score. Append is for like putting it in the array. Since we initialize the blank array, right? For precision, dot append will put it in the last, like a stack. Append. Okay. What will put the precision score. How will we get the precision score? From predefined precision score which we imported, like at the top, in which we put y test, y prediction. That's it, I guess. What zero division is equal to 0? Avoids errors if no positives predicted. Okay, zero division is equal to 0. Okay, now why is this an error? There's error here? No, right? Everything's fine. Hurry Bapri. Then we need to do recall. Recall will do it in the same way. Pretsa. I took Y pred ma. Sudeep. I took Y pred, not Preds. Then recall is TP by FP TP plus FN. Out of actual positives, how many did we catch? Okay. Precision we were checking how many in how many positives, how many of them were right. And recall we will sell out of actual positives, the available positives, how many did we catch? That is recall. True positive rate is also known as recall. Recalls, where is recalls? Oh, recall. Okay, now then accuracies is also same. I need to change a little bit. Accuracy, not accuracies, I took accuracy. Accuracy score, and y, not preds, I took y pred. Not capital Y, small y. We are done with this. Now we calculated precision, recall, accuracy for every threshold. Okay, now what I need to do, I need to plot these graphs. This is all easy, man. This is all basic, so I'm gonna type all of this. Fix the indentation, paste this. Done. Precisions, not precision, recall, accuracy. Done. Anything else? Nothing else. Let's run this and let's see. Name thresh values is not defined. Thresh val, man. Thresh values. Thresh values. Wow. What the hell is this? Precision decreases from left to right, as I said. You guys remember? If any was from the first stream, I said when I go from left to right, false positive and true positive decreases. Okay, since it decreases, what am I even saying? No, my bad. Baldstrawat 67. Thanks for the 67. Spam hundreds of 67. It's very slow speed right now. No? Default is 0.5. Precision increases like this. Sorry, I told wrong, right? Sorry. Precision is blue line. Now precision, what I told from left to right, false positive decreases. When false positive decreases, what happens? Precision increases. Why precision increases? Because true positive by true positive plus false positive. True denominator has false positive, and in denominator if false positive decreases, numerator value, all of those total value increases, and total value increases, precision increases. As you can see, as we go from left to right, increases. Okay, now then what about green? Green is accuracy. Hmm? Green is accuracy. Red is recall. Left to right. Sorry, left to right. Fn increases. Fn increases. Recall decreases. If recall is decreasing. Train a second simpler model. Now we need to learn this. This is the final of logistic regression. Precision increase. Precision increases because of you, my love. Don't make me shy, man. I am blushing right now. Okay. Then. This is the last step. Then we'll move to data. Till 5 I'll do the stream. Then I have to upload a reel. Then I have to write assignments and all. Then we'll see what to do. Okay. Let me go here. Like the stream, guys. Like the stream. Like the stream. Subscribe me. I need to have 1k subscribers so that I can earn money and buy a good setup for myself. Don't forget reels, man. Daily interest. Try to reach. Yeah. I'll put one today. Put a good one today too. Okay. I'm just keeping. We are training another simpler model now. How? Simple model is equal to simple feet, not simple model. Simple feet is equal to, it has only two features. I before in the model we did, it had many features. This one has minor axis length. Okay. Okay. X2 is equal to df of simple feeds dot values. I need to keep it capital. All of them have capital. Capital. Length. Axis. Major. Minor. Axis. Okay. Then I put this in this data frame which we had, where we put x2. Before we had x raw, we are having now x2 of df of simple what feet dot values. Okay, in x2 we are storing the values of those two columns. Okay, then we divide this into train test split. How do we do that? X2 train comma x2 test comma y test test is 0.2 only na. Yeah, random state is 42 and stratify is equal to y. Done. Then what ma? Hey, I need to ignore this. Why? Oh, because y is same. Oh, because y is same, right? We have changed only x. X is like x had before 7 features. Now we have made it to 2 features. So we have changed only x and y. Sorry, x. I don't need to do again for y. So if I need to ignore this, I just put a underscore, 2 underscores. Okay. Then we do standard scalar. Creates a scalar object. Standard scalar. In standard scalar, we fit transform the training data. x2 train s2 sc2 dot fit transform x2 dot train. Then we need to fit transform the test data, not fit transform. Remember, is only transform. Why? Because if you do fit transform, the model will learn from your test data and cheat during the examination. Okay. Apply same scaling to test data. Okay. Create logistic regression model. Okay. Creating the model. Then what do we do? Model 2 dot fit. What do we fit in that? x2 of train comma y train, and y2 probability predicts probability. Then we again compute the ROC curve. Same thing we did before. We just copy this. Let me run this. There is a beautiful error. Testa. Got it in test data, right? Test is 0.2. Test size is point. Oh, my bad. Random testa. Random state. My bad. Y prob 2. Y2 prob. Should be fine now. Aux core is not defined. What did I keep before? Accuracy? Not aux core. I kept it as. No, no, no. Let me go before. I kept it as bari sirf awk. Awk. Just awk. This is running finally. Now, damn, this has higher core, right? This has higher area. Hmm. We are done with logistic regression. We are done with logistic regression, man. Wait, I need to test my knowledge. I need to see the marks. Is everybody ready to test your knowledge? Let's go. Let's take the quiz. Increasing a binary classifier threshold is vaguely like which of the following: false positive and false negative, both degrees as we go from false positive and false positive and true negative decrease. So false positive increases is a wrong statement. False positive decreases is a right statement. False positive and false negative, no. False negative only increases, false positive decreases. So only this is option. Okay. The data set that you split into train test value set has 9 9 and no, absolutely not, because it's a very high imbalanced data set. You can't predict it on the accuracy metric. See, 99% of them has negative values and 2 of them have positive values. Obviously it will say negative all the time, and you will say accuracy is 99%. In general, when precision increases, what happens to recall? When precision increases, the recall decreases. Yeah. The points on binary classification models rock curve closest to 1 point generally represents the best performing thresholds for the model. Uh, Hello, Irfan Sheikh. Nice pink hands. The points on the binary classification models rock curve closest to 1 comma 1 generally represents the best performing thresholds for the model. No, I don't think so. I don't think so. Choosing threshold depends on your right. Do I know Irfan Sheikh personally by any chance? Does Irfan Sheikh know me personally by any chance? You are evaluating the performance of two binary classification models, Model A and Model B. Model A has an OC of zero point 0.5. Models for each predictions are made completely random. I'm learning. I have many leftover projects, man. I had made an AI historical interactive game. It's leftover kind of, where you have like multiple voice agents disguised in character and you interact with them to learn history. Like let's say partition of India. Okay, there were many characters were like Gandhiji, Nehru, Muhammad Ali Jinnah, and Mountbatten. Okay, so you get to talk to four of them instead of learning the history as it is. You get to talk to them. You get to change the history. You get to see if you were there at that time, what could the present be? What difference the present would bring? Okay, how can you affect the mindset of someone? That's how. That was, I think, almost I have worked on that project. Little bit of it left. I thought I should complete machine learning first, then I continue the projects again. But let's see. You're evaluating the performance of two Model A and Model B. Model A has an OC of zero point 0.5. Model B predictions are made completely randomly. Completely randomly. I don't know. Must be one of them must be wrong. All of them were right. This one is wrong. I'm not going on some guy. You tell me what's the answer. Oh, okay. Nice learning it. We have received the learning badge, guys. MLCC modules. Machine learning crash course, right? Working with numerical data. Thanks, Irfan Sheikh. I'll take a break. Drink milkshake. Talk something, guys. Talk about something. You guys can ask some questions if you want anything. Any help you need, anything. We. Oh, Irfan Sheikh is going. Bye, Irfan Sheikh. See you soon again. Any questions, guys? Anything? Let me know. Create a thumbnail like learning ML while milkshake arrive. I didn't get the joke. Basically, curious thumbnails, right? I'll work on YouTube more, man. I need to focus on YouTube more. See, I have 2 months. Creating a website in 30 minutes. Yeah, I have seen that. Tell me something, guys. Anybody who's joining, type something. Tell something. Be free. Express yourself when you joined, what you felt. Anything like that. Beyond typing.
I'm backy. We are moving to data. Let's start. Half an hour left. Let's start. Introduction. How do we work with numerical data is what we are going to learn tonight. ML practitioners spend far more time evaluating, cleaning, transforming data than building models. Data is so important that this course devotes 3 units to the topic: working with numerical data, working with categorical data sets, generalization, and overfitting. This unit focuses on numerical data. What does numerical data mean? The integer values, the floating point values, the double values. They are additive, they are countable, they are ordered, increasing or decreasing. The next unit will focus on categorical data. Examples of numerical data include temperature, weight, height, anything. Okay, the number of deer wandering in a nature preserve. What the fuck is an example? In contrast, your US postal codes, despite being 5 digit or 9 digit numbers, is not the twice the quantity of postal code. These numbers represent categories. Yeah, I understand. Something which is categories, specifically geographical. Now, let's say Bangalore has a pin code. I can't share my pin code because people will, fans come to your home, and that's very scary. It's difficult to handle the crowd. We don't even have bodyguards. So if I have a pin code of 1200, okay, and I multiply it by 2 twice, that is 1400. This is not additive, it's just random. They are like categories, okay? So that comes under categorical data. What comes under numerical data, which is additive? It's pin code, right? What do you say? Pin. Yeah, I don't think so, man. Pin code only, right? I don't know. Mumbai or something. I'll check Mumbai pin code. Zip codes are. Pin code only, right? Then, yeah, that's what I am saying. If it's adding it, you can twice it. See, temperature is 10 degrees Celsius. Twice of it is 20 degrees Celsius. Then they are all okay, okay, okay. Then temperature, then weight. Then what happens is this is numerical data. Okay. Another one is categorical data. That's it. There are two types of data. One is numerical data and categorical data. Next, let's come here. How a model ingests data using feature vectors. Okay. Until now, we've given you the impression that a model acts directly on the rows of a data set. However, model actually ingests data somewhat differently. For example, suppose a data set provides 5 columns, but only 2 of those columns, B and D, are features in the model. Okay. When processing the example in row 3, does the model simply grab the contents of the highlighted 2 cells as follows? I don't think so. In fact, In fact, the model actually ingests an array of floating point values called a feature vector. You can think of a feature vector as the floating point values comprising one example. Okay, it makes it as an array of those numbers. Okay. However, feature vectors seldom use the dataset's raw values. Instead, you must typically process the dataset values into representations that your model can better learn from. Instead, you must typically process the dataset values into representation that your model can better learn from. So, a more realistic feature might be, wouldn't a model produce better predictions by training from the actual values in the datasets from the altered values? Surprisingly, the answer is no. Wow. Did you guys see this? This is very beautiful. Wouldn't a model produce better predictions by training from the actual values in the dataset than from the altered values? Surprisingly, the answer is no. You must determine the best way to represent raw data values as trainable values in the feature vector. This process is called feature engineering. Oh my god. Feels like an introduction of a character. And it's a vital part of the machine learning. The most common feature engineering techniques are normalization and binning. The two feature engineering techniques are normalization and binning. Normalization means converting numerical values into a standard range. You make them put them into a particular range, that is normalization. Let's say you have very random values. One value is at 85,000, one value is at one a single digit. You put them both of them into a specific range, that is normalization. Binning is also known as bucketing, where you put no numerical values into buckets of ranges, like multiple ranges, I guess. So let's learn normalization and binning. Okay, every value in a feature vector must be a floating point value. Okay, however, many features are naturally strings or other non-numerical values. Consequently, a large part of feature engineering is representing non-numerical values as numerical values. You'll see a lot of this in later modules. Let's do. Before creating features vector, we recommend studying numerical data in two ways. Okay, visualize your data in plots or graphs, that is using matplotlibs or pandas. Get statistics about your data. Visualize your data. Graphs can help you find anomalies or patterns hiding in the data. Therefore, before getting too far into analysis, look at your data graphically, either as scatter plots or histograms. View graphs not only at the beginning of the data pipeline but also throughout data transformations. Visualizations help you continually check your assumptions. Let me go with working with missing data. Yes, sir, please show me. Pandas uses different sentinel values to represent a missing, also referred to as NaN, depending on the data type. NumPy.nam for num data types, to np. I know this. Statistically evaluate your data. Before visual analysis, your potential features and review gathering basic statistics. How do we get this? That is df.describe dot round of 2. You guys remember we did it in the code. And how do we do this? Working with mesh data, df dot is null, and we replace with some values or just delete those columns, right? Is null dot any. That's how we check the missing data. And visualization, how we do it from matplotlibs or seaborn. Okay, seaborn for convergence matrix, and seaborn for convergence matrix, and matplotlib for this one, logistic regression. Okay, mean and median standard deviation, we get this all in that one line, df.describe dot check that one. Okay, find outliers. Outliers are the points which are distance from your data set. See, you have data sets like, you have values like 1 2 3 4 5 6 7. Suddenly you have 80,000. 80,000 is an outlier because it's very far from your, very different from your actual most of your values. That's an outlier. An outlier is a value distant from other values in a feature or a label. Outliers often cause problems in model training, so finding outliers is important. When the delta between the zero differs significantly from the delta between the dataset, probably contains outliers. The delta means difference. Okay, when you do df.describe, I'll show it from the code, I guess. Let me go to the code. Jaldi. df.describe.round to. Yeah. When the difference between 0% and 25% ng is significantly higher, when you do this minus, When you find out the difference between 0 to 25% and the difference between 75% to 100%, when it shows, when it's very high, the both differences, then you say the data set as outliers, else you don't. The outlier is due to a mistake. For examples, perhaps an experimenter mistakenly entered an extra zero, or perhaps an instrument that gathered data malfunctioned. You'll generally delete examples containing mistake outliers. The outlier is a legitimate data point, not a mistake. In these days, will train ultimately needed to infer good predictions on these outliers. Okay, if not, let us apply more feature engineering techniques such as clipping. I'll stop this here, I guess. Do I need to continue till 5? Bending, scrubbing. I'll complete this tomorrow in some time, man. I have worked with this numerical data. I'll complete it tomorrow and start with categorical tomorrow itself. Categorical data is easy. Then Monday I will complete both of this. Tuesday I will start datasets. I'll complete datasets. Then Wednesday we'll start neural networks and all. Thursday real world ML. By Friday or Saturday I will start the projects, and by Sunday, boom, done with machine learning. But the thing is, you need to keep on revising whatever you have studied, okay? So that we don't fuck up, because we have studied very fast. There will be a positivity, sorry, positive. There will be a possibility that we forget concepts or have unclear concepts in a head, because of which we might need to revise daily for like some time, probably 15 to 30 minutes, so that we stay consistent and we know have an strong grip on machine learning. Okay, that's it for today, I guess. I'll share this Google Colab in the GitHub. You guys can refer to it. And yeah, thank you all. Bye bye. Thanks for joining. A lot of people joined today. Thank you so much. Bye bye. I'll see you tomorrow. We'll complete data section tomorrow and move to advanced ML models, that is neural networks, and lastly go with real world ML. Okay. Deep learning, I guess we have Codex. Deep learning. They don't have deep learning. Anyways, deep learning crash course I have. Learning crash course. Google. It's a book. Oh, there is a book for it. Damn. Mm. Whether you're an engineer optimizing models or introducing new data, we learn this, man. We learn this for deep learning, I guess. But it will take a lot of time, man. Capturing trends and recognizing patterns with dense neural networks, processing images with conventional neural networks, enhancing, generating, and segmenting. I'll probably see after machine learning. We have time, right? We have a full week. We'll see where to learn. Alright, guys. Bye bye. That was machine learning day 5. Thank you guys so much. See you again someday. Bye bye.